right, let's solve some of the practice problems from our formatted input-output lecture. All right, this covers in the C programming language, printf and scanf. So here are the practice problems you were given as supplemental exercises. And number 1 asks, what output did the following calls to printf produce? Well, we're going to discuss that, and we're also going to go ahead and program these. So what I'd like to do is I'm going to use code blocks. I'm going to create a new project, and I'm going to create an empty project instead of the console application we've been creating. All right, I will just call this practice formatted IO. And notice when it creates this project, it doesn't create a set of files for us, right? Console application gives us hello world. We're going to actually say file new. We're going to file new file, and I'm going to pick a C source file, and I'll just call this exercise 1, and I want to make sure I have the debug configuration in case I want to use the debugger. So now I'll say finish. Sorry, I didn't select a full path. I wanted to save it in that project file, so if I just click on the 3 dots, it automatically selects the folder it just created in that project environment. All right, and now you can see here, under sources, we have this exercise 1.c. All right, so let's put in a set of comments. Let's say, solutions to practice exercise number 1, formatted IO, right? And what I also like to do is I often just like to put the question in there. So I had copied that from the Word document. I thought I had. Let's copy that. All right, so there was our question. Right. I like to put in comments then just what I'm answering. Right, let's write a little C program so we can see what the actual output is. So we're going to use printf, so we'll need to include, include standard io.h. That's where the printf function is found. Remember, every C program starts with a main function. Because, all right, so now let's just go ahead and see what this generates. What output does that generate? And notice when I copied from a Word document, it didn't copy the double quotes correctly. Word is a rich text format, not a text editor, so sometimes when you copy, it will copy things in a way that source code doesn't understand. All right, so once I've corrected those double quotes now, let's talk about what we think the output will be, right? So the constant here, 86, its data type is integer, is going to get substituted into this conversion specifier here. So this conversion specifier, remember %d says I want you to print a decimal number, something in base 10, and it's going to be an integer. So %d is for an integer base 10. And 6 says what you want the field width to be. So when you print out the number 86, it wants a field width of at least 6 characters. Since 86 is only 2 characters wide, by default it's going to right justify, meaning we'll see 4 spaces to the left of the 86. Then it will print a comma, and then it will print a space. And now for this conversion specifier, it's going to substitute this constant here, 1040. All right, once again, %d says print an integer in base 10. 4 says leave a field width of 4. So after this space, since this is 4 characters wide, it will print out the 4 characters. So what I'd like to do now is I'm just going to build and run this. And And sometimes code blocks takes a second, first time I run, to pop up the terminal window. It's slowly compiling. All right, popped up the terminal window on my other screen. All right, notice there was no new line character here. Right, so you can see here we've got the 86. There should be 4 spaces to the left. We've got the comma, we've got the space, and then the 1040. Right, let's just go ahead and try B. I'm just going to copy that down there, lost my mouse. Thought I copied B, evidently not. All right. Let's fix those double quotes here. All right. So it looks like we're printing the same thing. The only difference between the two is we can see that this says %6D, meaning this number is already 4 characters wide. It's going to put in an additional 2 spaces to the left. And I'm just going to run both A and B at the same time so we can see those results. And let's just go ahead and put in a new line character so that we can see how these line up under one another. And I need to stop that, and then let's build and run. All right, so now you can see this first line is the result of A. The second line is the result of B. And notice this is shifted over by 2 more characters underneath. So this said use a field width of 6. Whenever the field width is bigger than the number we're trying to write, then what it will do is it will always then, by default, this is right justified, meaning this will add spaces to the left to make the field width that 6 wide. And the other friendly thing about using field widths is if I were to change this one to 3, notice this is 4 wide. It will always print out all of your numbers. So if you make the field width too small, the actual width of the number, the value it needs to print, will override this field width. So let's just build and run again to illustrate that point. And you can see now in this first line, even though I changed this from 4 to 3, it still printed out the entire number. So it overrode the fact that I didn't leave enough room for that. Right? These width specifiers can be very handy in terms of formatting our output. All right, so now we can just go ahead with the others as well and see what their output is. So let's take a look at, let's see here. And if you want, you can erase those, or we could always just comment those out. All right, let's take a look then at C. C says %, or this conversion specifier, %F. F stands for floating point type. All right, so that's actually going to print out. This constant is of type double. It's of part of the floating point family, right? Floating point has float, double, double, double. All right, so what it's going to do now is it's going to print out 6 decimal places to the right. The thing you want to remember about printing out floating point information, if you don't specify the number of decimal points, it always defaults to 6. All right, let's just go ahead and build and run. And we'll see that. And 2, 2, 3, 1, and it appends 2 zeros to the right to make that field width to the right of the decimal point 6. And then what D is going to do is it's going to print out the same number. Let's look at D and E at the same time. All right, so we can compare them line by line. I need to. All right. So D has %.1. That means only show 1 decimal point to the right of the decimal place. Point 2 says show 2 decimal places. So let's actually build and run this so we can see how all of these compare. Well, let me put the new line character here. To make our output a little more readable. All right. So here's this line. We got our 6 decimal places. The 0.1f gave us the 1. The 0.2f gave us the 2. Now, it doesn't always round. If you need to round, you can't count on a floating point always rounding. Right? There is a rounding function if you need something to round in the math library that you can call, but you don't want to assume that everything always rounds here, because it does not. Sometimes it will, sometimes it won't. All right, let's take a look at these other types of data then. All right. All right, so these are floating point examples. All right. Let's take a look at character data. All right, so this is a character constant. Remember, a single quote around a letter or a digit means it's a character constant. All right, let's just go ahead and take a look at an ASCII table. I'm going to pop up the ASCII table here. All right, let's look at the digit 2. Let me make this a little bigger on the screen. Here, see here is the character 2. So this is a character for the digit 2. It's stored in memory, and base 10 is the decimal integer with the number 50, hexadecimal 32. Right. So here in this printf statement, when we use the specifier %c, that says to print out the character value. So the character value of this is actually the digit 2. %d says to print out the integer value, so we should see the number 50 coming to the screen for this character. And %x says to determine, or to take that binary pattern and show it as a hexadecimal pattern, so we should see the number 32. Let's actually build and run, and actually I want new lines in here. And it also does not like my character data. It just came up with an entry saying I have a stray \221 in here. So I actually sorry about the dog. He heard something he did not like outside. All right. So let's get rid of this Word document problems here with the character data. And now let me build and run this. All right. So when that pops up our screen, this %c gives the output of the character 2. %d says to interpret that binary pattern as a base 10 integer, and it gave us a 50. And then %x said to interpret that binary pattern as a 32. Let's add in a comment here that note the character 2 is represented with the binary number 32 in memory. Okay. %C says to interpret the binary as the character 2 and display it. Right? %D says to interpret let's correct my spelling. Interpret. So remember, things are stored in memory in binary, strings of zeros and ones. So it says, look at that, what's stored in memory, that binary 00110010 as the integer, as the base 10 integer, right? And %x says to interpret the binary 00110010 as the base 16 value and display it. So that's the purpose of these conversion specifiers. It goes out, looks at what's in memory, and it tells it how to interpret it or how to convert it. Convert it from binary, in this case, to a character. %D, convert it to an integer. %x, convert it to hexadecimal. Right? We want it to be understandable for humans, and we're not used to seeing long strings of binary and making sense out of them. Right? So this says how to convert what's in memory and display it for our purposes. Right, that was the point of this exercise then. We took a look at how field widths worked with integer data. So, integer data, field width examples. Right. We took a look at floating point, how to control the numbers to the right of the decimal point, and then how to interpret character data. And that was the point of exercise number 1.